Welcome to the third part. So, as we were saying that we now have our three data and all of them are clipped to our area of interest. So, the land cover, if you want to clip a raster, you just come here to raster, then extraction, then clip by mask layer. So, that one will allow you to clip land cover and DEM. For soil, you come to vector and then your processing tool, then clip. So we already have our tray clip. Now the next thing we're going to do is to change this soil, which is a vector, into raster. So safely you come to conversion under the raster, then rasterize vector to raster. Input is going to be U, which is our soil data for Sengishu. Then use a band field, we use the numbers is known. Then output size units, I'm going to put pixel. Then resolution, and use as high resolution as you want, but to me I'm going to use 500 to ensure that my pixel appears a little bit smooth as possible. So there I go, I've used 500 and output extent you can leave it as default because we don't need to clip it further. We only are interested in the soils of Sengishu. So the rest I'm going to leave as default, and then I'm going to save this onto file. Then I'll name it soils underscore u. So soils underscore u. Then I say run. Okay. Then I close this one. Now you can see that this one I can. I think I'll use it. So you can see our soil percentage has been turned from vector to raster. So you can change the symbology by properties and symbology. Then here on render type, click on calculated unique values, then classify. You can see the numbers are here according to the SNAM. Okay, now click on apply. Okay, so this one have the values. So it is classified according to the values. Okay, now we are going to do something called raster reclassification of all these three data. We're going to reclassify the soils, land cover, and DEM. So now, first of all, you need somewhere to rewrite these values. The values down, you need to rewrite them, and then we'll see which values stand for. So I've already written them down somewhere, and just write it somewhere here. So the value 42 stands for the soil type FO. The value 406 stands for the soil BH. The value 498 stands for soil type FO. The value for 823 stands for NE. NA. The value 848 stands for NH. So here we go. So when you've done that one, cross-check through the soil, the initial soil that I have removed that was in vector. You'll see the attribute table, and then there's those columns of DOM soil. So you cross-check, then you'll see the abbreviations. Then you can easily check the full name over here. This one I'll post it on the description of the video. So you cross-check the full name there, and then from there you can get the full description of a specific type of soil. So I'm going to move to raster reclassification. So there's a tool called R.reclass. This one is found in grass. So if at all you don't have grass, you can just search for it in the plugins, but it should be there available. So double click on reclassify. I want to start with the DEM. To reclassify my DEM. So first of all, before I reclassify my DEM, I want us to check our DEM distribution. We are going to use a span of 5 classes, so I'm going to change this one into pseudo. When changing it into pseudo, ensure it is in 5 classes, then I put this on unique interval. So it will be classified into 5 groups. So this one again, you need to write it down somewhere and then give it a grouping. You need to write it down somewhere the way it is and give it a grouping. So after we've done this one and created 5 classes, you can see our lowest or our lowest point according to terrain is 1592, and then the highest point is 2852. So there's something you should know about suitability analysis, is that for us, we are going to create 5 classes in each raster, and then 1 stands for not suitable, areas that are not suitable, then 2 stands for less suitable, then 3 stands for marginally suitable, 4 stands for moderately suitable, 5 stands for highly suitable. So for our case, the lowest area was 1592, and according to cultivation, this one is gently slopy, so this area is highly suitable. Okay, and then this one is on a very high terrain, so we can say something like hilly or just a steep slope. We expect the area to be a bit steepy, so this one is the least suitable, not suitable at all, because issues with soil erosion will be a challenge, and we expect the soils from that area to not be that mature. Okay, so we're going to do this. This one was our list, 1592. So somewhere you just create like a margin of 5 classes. So you'll start by 1500 to 1592. This one is 5. We said 5. 5 stands for highly soluble, suitable. Okay, so you classify like that. Then 1592, then you add 1, come here, 1593 to 1907. These values here are the ones that are here. Okay, so you just create a margin of classes. So that's what I've done. So 1593 to this one is 4, then like that, up to the highest point, which is 2857, which is equals to 1. So